Assalamualaikum. This is example 4 based on the Bernoulli's principle or Bernoulli's equation question. Okay. So this is the question. Water flows from a large tank through a large pipe that splits into two smaller pipes as shown in figure 2. Okay. In this figure, we have one pipe divided into two flow rate. Okay, we have pipe A here with 2 cm diameter, pipe A, and we have pipe B here for diameter 3 cm. So by neglecting the viscous effect, okay, so find A, calculate the discharge at pipe A. So we have to find what is Q at pipe A. And then second, calculate the discharge at pipe B. So we have to find what is this discharge at pipe B. And then C, calculate the discharge at point 1. So we have to calculate what is the discharge at point 1. And then last question is calculate the pressure at point 1. So what is the pressure? Another question based on point number 1 is what is the pressure at this point? Okay, point number 1. So how to solve this problem? So we know that we have two different equations in order for us to determine what is the discharge. First is continuity equation. Second is Bernoulli's equation. So this is number 1 and this is number 2. So can we solve by using continuity equation for number 1? So let's take a look at this figure. So to find discharge at point A, we have to have discharge at point B and discharge at point 1. But at this in this question, we are not being given the values for the discharge at point 1 and point B. We can use velocity to find Q. Then take a look at the velocity. Do we have velocity at point 1? So take a look at this question. Is there any velocity mentioned or velocity given for the point number 1 and point B? No. So therefore, we cannot use continuity equation to solve discharge at point A. Now, our only option is by using Bernoulli's equation. So we solve for the point number 1 first. So calculate the discharge at pipe A. So to find the discharge, we know that the equation for discharge is Q equal to UA. Okay, can we solve A? Area for AA? Yes, area at A we can solve it. Now, we do not know what is the value for the velocity at point A. Therefore, we have to apply Bernoulli's equation. Now, this is our point number 2. So we have to select point number 1. Okay, we have 1, 2, and at the surface is point 3. We have 3 points. Where is the point that is suitable for us to select as our point number 1? Let's say I select point number 1 at 1. Do we have pressure here? No. That's why we have to calculate pressure at point 1 at question D. And then if we do not have any pressure value at point 1, we cannot choose point number 1. It will make your solution complicated. What about B? Do we have pressure at B? Yes, P atm. And then goes to velocity. Do we have any velocity point? So first is pressure. Yes, because we goes to the atmospheric pressure. What about velocity? Do we have velocity value at point B? We can solve it using continuity equation. Again, to solve the continuity equation, we must have velocity at point 1, velocity at A, and velocity at B, or velocity at 1 or B or A. Then we can solve point velocity at point B. And in this question, we do not have any of these 3-point velocities. Therefore, u here is remain unknown. What about z? Yes, we do have z values here. Now we have only one unknown here. If we combine with this unknown velocity at here, so we cannot solve for the velocity at point 2. If we apply the continuity equation, it will remain 3 unknown in your Bernoulli's equation. Therefore, I will choose point number 1 here is at the surface of this tank. So when we take a look at point number 1, do we have pressure value? Yes. What about u? Velocity? Yes, velocity at the surface of this water in the tank is 0 meter per second. Please refer to my previous videos that mention about the velocity on the surface of this tank. What about z? Yes, we do have z value. So my point is point number 1 to point number 2 here. So apply the Bernoulli's equation to find what is value of velocity at point B. So now I will apply. So this is question number 1. Apply velocities. Point 1 rho g plus u1 square over 2g plus z1 equal to, we have to find at point A. Therefore, I will change this P to PA over rho g plus UA square over 2G plus ZA. Now we have to cancel out a few terms in this Bernoulli's equation. We know that P1 and PA is atmospheric pressure. So take a look at here. The tank is open to atmosphere. 1 is P atm. 2 also P atm. So we can cancel out here PA and P1. What about U1? U1 also 0 because at surface of tank. So the equation will becomes UA square over 2G equal to Z1 minus Z2, not Z2, ZA. Okay. So your UA is equal to Z1 minus ZA to G, because we want to find what is the velocity at A in order to find what is the discharge at point A. So now I will select Z1 as my datum. So Z1 is my datum, then 0 meter. So ZA is, take a look at here, ZA, point number 2 is below point number 1. 3 meter below point number 1. Point number 2, 3 meter below point number 1. Therefore, we have to substitute negative 3 meter. Negative 3 meter in your equation. So, substitute your value. So, Z1 is 0 minus 3 meter. So, times with 2, 9.81 meter per second. So your UA is equal to 7.67 meter per second. You already solved for the velocity at point A. Now we have to calculate what is the discharge. Am I right? Discharge at pipe A. So the discharge at QA is equal to UA times with AA. So UA is 7.67 0.67 meter per second. And then your UA is cross-sectional area by the diameter for A is 2 times 10 to the power of minus 2. This is in centimeter, so you have to change into meter. So square divided by 4. Therefore, your QA is equal to 2.41 times 10 to the power of minus 3 meter cube per second. So you already solved the first question A. Now we move to question B. So what is question B? Calculate the discharge at point B. Again, you have to select your point. It is the same as before. So point B will become your number 2, point 2. And then you have to select point number 1, either at point 1, point A or point 1 here. Okay, at the surface of the tank, water in the tank. Now the easiest and less complex, the easiest solution or the easiest point that you have to select is point number 1. So it is the same as previous question for A. So we have to select point 1 at the surface of the water in the tank, and then point number 2, your point number 2 will be at point B. So now, this is B. So P1 rho G plus U1 square over 2G plus Z1 equal to, so you have to calculate what is PB at point B, velocity at point B. Therefore, here I change from P2 to PB plus UB square over 2G plus ZB. So now we have to cancel out a few points or a few terms in your Bernoulli's equation. P1 is P at the M, U1 also 0, so 0, 0. PB atmospheric, so it will be 0. So your equation will be the same as before, where you have Z1 minus ZB, Z1 minus ZB times with 2G. Now we have to calculate, you have to select. So I will select Z1 as my datum, so 0 meter. What about ZB? So take a look at this figure. So ZB is 7 meter below than point 1. Therefore, you have to substitute negative 7 in your equation. So negative 7 meter. So substitute your value. So UB equal to 0 minus 7. So times with 2 times with 9.81 meter per second. So your UB is equal to 11.719 meter per second. So to find discharge, so you have to multiply your velocity at point B with area at point B. So your QB is UB times with AB. So UB is 11.719 times with pi. Diameter at B is 3 times 10 to the power of minus 2 square over 4. So you will get your QB is 8.28 times 10 to the power of minus 3 meter cube per second. So at this point, for the point B, you cannot use the Bernoulli's equation. You cannot use continuity equation. Why? Because at point 1, we still unknown. The velocity at point 1 still unknown. Therefore, you cannot solve it by using continuity equation. You have to use Bernoulli's equation in order for you to determine what is the velocity at point B. Now we move to point C. Calculate the discharge at point 1. So we already determined what is the discharge at point A and what is the discharge at point B. So to find what is the discharge at point 1 or volumetric flow rate at point 1, you have to sum up QA and QB, because this Q is a total flow rate of a total flow rate where you have to sum. You have to add values for QA with QB, because this is a total flow rate. This total flow rate will divide into QA and QB. So your question C is Q at point 1 is equal to Q at point A plus Q at point B. So you already determined what is the discharge at A and B. So when you sum up those values, you will get value for Q1 is equivalent to 0.0107 meter cube per second. This is the total discharge, okay, that will be divided into two separate pipes, QA and QB. Now we go to question D. So your question D asks about the pressure at point 1. So you have to select point. Point number 1 will be your point number 2. Or maybe you can select this as your point number 1, because we already determined what is the velocity at point A and what is the pressure at point A and pressure at point B and velocity at point B. You may select either point 1 to point 2 here. Take a look at my pen. Point 1 here, 2.2 here, or you can select point 1 here to point A. Okay, you can apply Bernoulli's principle from point 1 here to point 2 here, or point 1 here to point A, or point 1 here to point B. It's up to you which point that you that okay with you, because you have 3 points that can be chosen. Okay, for me, I will choose point 1 here, and this point will becomes point number 2. Okay, now so my point 1 is at the surface of the water tank. Then I apply Bernoulli's principle. So U1 square over 2G. Because why I choose point number 1 at the surface of the tank? Because there is so many terms that can be 0. Then I will reduce the complexity of solving that question. Okay, so my point 2, I will write down here as a point 2, but here we want to find what is the pressure at 2. Pressure at 2 is pressure at this point. Okay, so my P2 plus U2 square over 2G plus Z2. So now I will remove a few of these terms in the Bernoulli's equation. P1 is P at the M, U1 is 0, and then that's all. So rearrange the equation, we will get P2 equal to rho G times with Z1 minus Z2, okay, minus U2 square over 2G. So now we have to find what is the velocity at this point. Okay, point number 1. So to find velocity at point number 1, we have to apply discharge equation. So Q2 equal to U2 A. Okay, Q2 is Q at 1 lah. Okay, U at 1, A at 1. Okay, so rearrange to find what is U1 and Q at 1 over A at 1. So substitute all the values, you will get U at 1 is equal to 5.45 meter per second. Okay, A at 1 is area with the diameter of 5 centimeters. Okay, substitute, then you will get U at 1 is 5.45. So this is velocity at point 1. Now, in my Bernoulli's equation, point U11 is my U2. So I substitute velocity into this equation, okay, to this term. So substitute the value. So P2 equal to 1000 times with 9.81. So my datum will be Z1 minus, okay, my datum Z1. Okay, point number 1, point number 2, my point number 2 is 7 meter below point number 1. Therefore, I will substitute negative 7 into my equation. So negative 7, okay, minus 5.45 square over 2 times 9.81. So from here, I will get my pressure at point 2 is 53818.75 Pascal. So pressure point 2 is P at 1. So I already solved the last question where we have to find what is the pressure at point 1. Okay, that's all. Thank you.